Hi guys, I'm going to show you a quick way to make a table on parabolas using Desmos graphing. So we're going to graph a function. So once it pulls up, I'll get rid of these. Out, 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 out. This was some sort of a lesson, but I'm just getting out of it. Okay, so if I wanted to graph a parabola, let's say I had 2x squared. And the squaring of it, of course, you're going to use the caret key, which is shift 6, 2, to get the second power, makes it the parabola. And again, we're just now learning that that alone makes it a parabola. The 2 makes it a little more narrow. And then when I add stuff to it, oops, I should say minus 2. Okay, so here we have this parabola. And this is your equation, and you have to do this in Alex. And I'm going to tell you that the easiest and the best way to do that is to make your own table of values. And using the formula of negative b, so negative 3 divided by 2 times your a. So I'm just telling you, once you have that, that's your x value. And then you substitute that value back in to get your y value to find this vertex. Now, as you can see, this vertex here is not an exact value. And so sometimes when you don't have that and you're looking at this, you're not going to be able to use these values in Alex because it's not going to like it, especially if this has 3 numbers. So like after the decimal, like 0.125. I think this one might be fine, but like your 0.333 is repeating and it's not an exact point. So sometimes you have to figure out if it's rational or irrational, these decimals. If it's irrational, like 0.333, it's not an exact amount. Hopefully you guys know that's 1/3. And maybe you can't even put that in your calculator. It makes it more difficult. So you have to make a table. So in order to make a table and try to do your best with this, if you cannot remember that formula or how to make your own table, you go up here and you hit this plus sign and it says table. Now I need to get rid of that 1 for that x, and I need to get rid of this and put my equation. So 2x squared. So again, squared. Pop back down. Sometimes it's enter. How do I get back down? Come on. Well, it's not being very, there it goes. Plus 3x minus 2. Okay, so here we have our x value and our equation. Sometimes you have to leave that 1 there, sometimes not. So here, I think when you have an exponent, for example, if you had x to the first power or different powers, that's why you need x with the 1, because it's telling you what to substitute where that exponent is. But here we don't have that. So if I put, if I'm looking at my graph, I can see most of my values are over here in this range. So I think if I know that this is here, I might put like -1. What does it give me? Oh, a -3. So that's a good number. So now I'm going to kind of go, well, what happens if it's 0? Well, that's also good. How about a +1? That's also good. How about a +2? Ooh, I'm getting kind of high, but I might be okay. Let's do the -2. Ah, that worked better. So you can see I'm kind of guessing along here trying to get those values. Sometimes on Alex, they want those exact values. They want you to have that vertex. And again, we know this vertex is -0.75. And sometimes you can even use, for example, I could change this to like a -0.5. I can make that a decimal. And if I said 0.75, was that negative? I can't remember. Was that negative? Yes. So if I made that a negative 0.75, so negative 0.75, that looks like an exact answer. So you might be okay with that, but be careful. That may not always. If there's 3 here, that may not be an exact answer. So you might have to use that formula, which is your negative b divided by 2 times a to get your x value, and then substitute it in to get your y. I hope this helps. I know it's hard to remember how to make these tables and when to use these tables, and if it doesn't work out, how to use these tables, but there you go.